Hello everyone, in today's topic we are going to talk about squares and square roots. And here are the learning goals. Students will be able to identify perfect squares and non-perfect squares. Students will be able to estimate and calculate the square root of a whole number. Square of a number. Squaring a number means to raise a number to the second power. So if we have 4 squared, it is equal to 4 times 4, which is equal to 16. And if we have 9 squared, it is equal to 9 times 9, which is equal to 81. And if we have 16 squared, it means that it is equal to 16 times 16, which is equal to 256. The square root of a number is the number you can multiply by itself to give you that number. So if we have a square root of 4, it is equal to 2 because 2 squared is equal to 4. Square root of 9 is equal to 3 because 3 squared is equal to 9. So therefore, when you take the square root of a number, it is the reverse of taking its square or squaring it. So square root of 64 is equal to 8 because 8 squared is equal to 64. Square root of 144 equals 12 because 12 squared equals 144. And square root of 1 equals 1 because 1 squared equals 1. So taking the square root of a number is simply the inverse of squaring a number. And square root of 0 is equal to 0 because 0 squared is equal to 0. So let us go to perfect squares. Perfect square is perfect because its square root is a whole number. So example for this one, 49 is a perfect square because square root of 49 equals 7. So when you square any number, it is a perfect square already. So 7 times 7 is equal to 49. Like 8 squared, it is equal to 8 times 8. So it is 64. So 64 is a perfect square. Or 3 times 3 is equal to 9. So therefore, 9 is a perfect square. Now let's move on to non-perfect squares. So a non-perfect square is a number whose square root is not a whole number. So in here, example, 40 is not a perfect square. Why? Because square root of 40 is equal to approximately equal to 6.3245 and so on and so forth. So as you can see, the square root is not a whole number. So therefore, it is a non-perfect square. So any number, if you extract its square root and you find it out that it is not a whole number, then it is a non-perfect squares. Now let us approximate square roots. You need to estimate the value of non-perfect squares by determining which two perfect squares they fall in between. So example, 11 is a non-perfect square, and 11 falls between perfect squares 9 and 16. So therefore, square root of 11 is between square root of 9 and square root of 16. So since square root of 9 equals 3 and square root of 16 equals 4, then square root of 11 is between 3 and 4. That is how we approximate square roots. Now let us find the two consecutive numbers the following non-perfect square fall between. So first, let us have square root of 55. Square root of 55 falls between square root of 49 and square root of 64. So therefore, its square root falls between 7 and 8. Square root of 49 is 7. Square root of 64 is 8. Now let us have square root of 23. Square root of 23 falls between square root of 16 and square root of 25. So therefore, its square root falls between 4 and 5. Now let us have square root of 5. Square root of 5 falls between square root of 4 and square root of 9. So therefore, its square root falls between 2 and 3 because square root of 4 is 2 and square root of 9 is 3. And for square root of 14, it falls between square root of 9 and square root of 16. So therefore, its square root falls between 3 and 4. And now let us have square root of 44. It falls between square root of 36 and square root of 49. So therefore, its square root falls between 6 and 7 because square root of 36 is 6 and square root of 49 is 7. That is how we approximate the square root of a non-perfect square. Now, let us find the square root by factorization. So why I'm using SpongeBob SquarePants? Because of the word square root. Okay? Now let us start with square root of 12. So in here, the first thing we need to do is to use the factor tree in order to determine the prime factors of 12. So always remember when you are using the factor tree, think of the first or the smallest prime factor or prime number that can divide the number. So the smallest prime number that can divide 12 is 2. So divided by 2, it is 12 divided by 2 is equal to 6. And then we further factor out 6, which is equal to 2 times 3. So therefore, square root of 12 equals square root of 2 times 2 times 3. And then rewriting 2 times 2, it is equal to 2 squared. And square root of 2 squared, it is equal to 2. Then we just need to copy square root of 3. So therefore, square root of 12 equals 2 square root of 3. Now let us have square root of 200. In here, we are going to use the factor tree again in order to determine the prime factors of 200. So let us start with 2 because it is the smallest prime number that can divide 200. So 2 times 100, and then 100 equals 2 times 50, and 50 is equal to 2 times 25, and 25 equals 5 times 5. Rewriting square root of 200, it is equal to square root of 2 squared because we have 2 there, and then times 5 squared, we have 2 5s, and then we have our remaining 2. So times 2. In here, we shall have 2 times 5 because the square root of 2 squared is 2 and the square root of 5 squared is 5. And then we just need to copy square root of 2. So we will be having 2 times 5 is equal to 10. And then we copy square root of 2. So square root of 200 equals 10 is square root of 2. Here's another way in order to determine the square root of non-perfect square numbers. So square root of 12, we go back to our first example. Just think of the factors of 12, wherein one of the factors is a perfect square. So we all know that 12 equals 4 times 3. So in here, 4 is a perfect square, so square root of 4 is 2. Then we just need to copy square root of 3. So therefore, we have the same answer using the factor tree or prime factorization. Now let us have another one, square root of 200. So in here, think of the factors of 200, wherein one of the factors is a perfect square. So it is 100. So therefore, Square root of 100 times 2. It is equal to, square root of 100 is 10, so therefore 10 square root of 2. So we derive the same answer using this method. Now let us have square root of 288. We all know that the factors of 288, wherein one factors is a perfect square, is 144. So square root of 288 equals 144 times 2. And square root of 144 is 12. So we have 12 square root of 2. Now let us have the other one, square root of 1200. So the factors of 1200, wherein one of the factors is a perfect square, are 403. And square root of 400 is 20. And just copy square root of 3. So therefore, square root of 1200 equals 20 square root of 3. So that's it for now. Please do your practice. Exercise 2E, page 36. See you again next time. Bye!